in Senior Advanced of Agora Math Circle. Today we will be going over the classwork for Senior Beginner Session 6. Let's start. We are going to start by solving question number 1. For questions 1, 2, 3, 4, and 5, we will be using the following set. Alright, so we want to find the range of the above set for the first question. To find the range, we should reorder the set, just in case we have lots of numbers and we might get confused on what's the biggest. So when you reorder the set, you get the following. You would reorder it from the least number to the greatest number. And since the range is subtracting the smallest number from the biggest number, we would want to find those numbers. So the smallest number we can see is 0, and the biggest number is 6. So to find the range, we subtract the smallest number from the biggest number. So we get 6 minus 0, so our answer is 6. Alright, let's move on to our second question where we're using the same set. The question is, what is the average of that set? Well, the average of a set is when you take the numbers, you add them all together, and you divide by the number of numbers. So let's start by adding the following numbers together. So 0 plus 1 is 1. 1 plus 6 twos, so 6 times 2 is 12, would be 13. 3 times 4 is 12. So 4 threes, so 3 times 4 is 12. So 13 plus 12 is 25. 1 5, making it 30. And 1 6, making the sum equal to 36. Now we have to divide by the number of numbers that we have. We have 14 numbers. So we take 36 and we divide it by 14. This can be equivalent to 18 over 7. You can write your answer as either 2 and 4/7 as a mixed number, or roughly 2.57. Let's move on to question 3. Question 3 says, what is the median of the same set? We need to reorganize the set, so we will use the one we already have, just this one. So the median is the middle number, but since we have an even number of numbers, there is no middle number. So we take the two numbers that are closest to the middle. That would be this one, being the 7th number, and this one being the 8th number, which are the closest to the middle. To find the median, we need to take the average of these numbers. So we add 2 and 2 to get 4, and the average is dividing by the number of numbers, and we have 2 numbers. So 4 divided by 2 is 2, which is our answer. We are solving question 4. The question uses the same set we used for the previous questions. For question, which is this set, the question said, what is the mode of the above set? The mode means the number that appears the most frequently in the above set. So we look for the number that appears the most. We see 3 appears 4 times, which is a lot, but 2 appears 1, 2, 3, 4, 5, 6 times. So since 2 appears 6 times, which is the most, 2 is the mode. Moving on to question 5, it says that we have to draw the graph based on the following set. So basically this would be game number 1 and game number 2 and game number 3, and we have to organize it, and this is how many points. So it gives us a start with the points 1, 1, 2, 2, 3, 3, and 3, 4. So now the next thing is 3. So 3, so it's the 5th game, and we score 3 points. So you draw a point right about here, and you connect the line. Now we move to the next. The next number is 5. So we have 5 points, and it's the 6th game. We have 1, 2, 3, 5 points before this, so it's the 6th game. So we have 5 points, 6th game, around here. So now we move on to the next game, and we could repeat this process. So there's 3 points, and it's the 7th game. Next, we have 6 points for the 8th game. Alright. Now, we have 2 points for the 9th game. So 2 is here, 9 is here. So this is just basic graphing. Sorry. Next, we have 2 points for the 10th game. Now we have 2 points for the 11th game. As for the 12th game, we have no points. So we just draw the line all the way down to the 12th game at 0, because there's 0 points, and it's the 12th game. 0 3-pointers. Now, for the 13th game, we have 2 points. And for the 14th game, we have 2 points. So the graph is going to look something like this. We are solving question number 6. The problem uses this set. The question is, which of the following statements is true? It says A with the following options. So, all of these options use the mean, median, and mode. So we might as well find these values and see which of them is right. So, we first rearrange the numbers. That way we can have an easy way to calculate the mean, median, and mode. We get this set. Alright. So the median is the middle number in the set. As we have 9 numbers, that's an odd number, it would be the 5th number. So the 5th number in this set is 2, which is the median. Alright. Now we calculate the mode. So the mode is the number that appears the most times. 3 appears 3 times, which is the most out of any number in the set. So these 3, this would be the mode. Finally, we move to the mean. So the mean is when we add all the numbers and we divide by the number of numbers that we have. So, we first add all the numbers. We get that 0 plus 0 plus 1 plus 1 plus 2 plus 2 plus 3 plus 3 plus 3 is 15. Now we take 15 and we divide it by the number of numbers we have. So we have 9 numbers here, and we take 15 and we divide it by 9, and we get 5/3, or roughly 1.67. Now that we've found the mean, the median, and the mode, we can fill out our obligations. The mean, of course, is the smallest. Second, we have the median. And then the mode is the largest. So the order is mean is less than median, which is less than mode. We can check this and we figure out that it is option C, which is our answer. We are now doing problem 7. So, problem 7 uses the following set. The question is, if the average of the above set is 92, what is the value of x? So, what we first do is we use the fact that we have an average. So, the sum is 5 times the average. The reason of this is when you have the average, you can write it as A plus B plus C plus D plus E over 5 equals 92. Then the sum of the numbers would be just this times 5. So basically, you would take the number of numbers and you would multiply it by 92 to get the sum of the following numbers. So you can multiply this by 5 and you get the sum of the numbers, which is this, equals 5 times 92. And 92 times 5 is 460. So for solving for x, we use the chart above. So we already have 4 numbers. So what we do is we take the 4 numbers and we add them. That gives us 368. So 368 plus x is 460. Subtracting 368 from both sides, we get x is 92. Let's go to problem 8. Let's go to problem 8. The problem 8 says, if the median of a set is 6 feet 4 inches, what is the shortest that the tallest person can be? Since we have no other requirements, we can start with the basic set of just 6 feet 4 inches. So we just start with that. This can literally be a set. So we know that 6 feet 4 inches is the minimum right now. Can we do 6 feet 3 inches? If we did 6 feet 3 inches, in order for 6 feet 4 inches to be the median, then it would either have to be there or a bigger number, bigger than 6 feet 4 inches would have to be there, like 6 feet 5 inches. So it could average out, making the median 6 feet 4 inches. So the smallest we can have the tallest person be on the team is 6 feet 4 inches. We are doing problem 9 now. 3 people were in an election. One person got 45% of votes, another got 30%, and one had 25% of votes. If the person who got 30% of votes got 36 votes, how many votes were cast? We can solve this using simpler percentage ratios. So if 30% is 36, we can divide both sides by 3 and get that 10% is 12. Now once we have that, we can multiply both sides by 10 to get that 100% is 120. So there were 120 votes cast. Moving on to problem 10. What percent of males surveyed listened to the station? So we see in our chart that we have males, we don't know how many listen, but we know 26 don't listen. And we have females, we know 58 listen, we don't know how many don't listen, and we have 96 total. For total, we have 136 people that listen, 64 people that don't listen, adding up to 200. We can start by finding the number of males that listen. We can find this by taking the total and subtracting it from the number of females. So we take 136 minus 58, and we get 78. Now, we have to find the total number of people for males. So we have 78 that listen, 26 that don't listen. So 78 plus 26 is 104. An alternate way to find this is to take our total and subtract it from 90. No, take our total and subtract the number of females from it, and we get the number of total males. In any case, we have 104. Then we get 78 over 104. Let's simplify this fraction. Dividing both sides by 2, we get 39 over 52. Then, if we divide both sides by 13, we get 3 over 4. So 3 over 4 is 75%. And 75% is the number of percent of males that listen to the station. So, problem 11 now. Where would the mean, median, and mode be on the graph? Well, the mode is the thing that appears the most. So the mode is the highest point. Judging by it, we see here. So in here, we would write mode. Next, we move on to the median. The mean is quite hard to find, so we look for which is in the center for median. So it looks more like this point is in the center, as this point is off to the side over here. So this point would be the median, because it's more in the center. Even though we didn't find exactly where the mean is, we can conclude it is in this spot, as there is no other spot remaining for it. So that means there's a mean here, median here, and mode here, and we're done. We are solving question number 12. Question 12 says, draw a table and make a bar graph based on the information given above. We have the times in seconds: 10 seconds, 10.5 seconds, 11.5 seconds, 11.4 seconds, 9.3 seconds, 9.4 seconds, 9.1 seconds, 8.8 seconds, and 9.8 seconds. 9.8 seconds, and of course 10.1 seconds, 9.3 seconds, and 11.4 seconds. So let's first make our table. So we want to know, let's make a table that will help us base on our bar graph. So our first section is time range, and our second section is number of students. So we take the time range 850 to 8.99, and we see that there's only one student who falls in that range. One student that falls in that range. Which would be this student. So we can cross him off now that we're done. So as we said, now we have 9 to 9.49. So how many students go from 9 to 9.49? Well, we have 4 of them. We have 9.3, 9.1, 9.4, and 9.3. We have this one, this one, this one, and this one. I'll leave 8.8 underlined as well because we already used that. So we have 4 students. 4, 9 to 9.9. All right, now let's move on to 9.50 to 9.99. We have only one thing that's in this section, which is 9.8. All the other ones are in 2 digits without the decimal point. So there's only one student for this section. Now let's look at 10.00 to 10.49. Well, we have 2. We have 10.1 and 10.0. So these 2 are in our section. So we have 2 things. Now we look in the section 10.5 to 10.99. We only have 1 in this section, which is the one on 10.5. The rest of these are all in the 11 section. So we have 1 over here. Now we have the section 11.00 to 11.49. So, in this section, we have 11.4 and 11.4 here. So there are 2 in this section. Now for the next section, which is 11.50 to 12.50, we have our last thing, which is 11.5. So there would be 1 here. Alright, now let's move on to the bar graph. What we need to do for the bar graph is use each of our things and draw for the number of people they have. So from 8 to 8.5, we have 1 people. We have no one, actually. Sorry, we have no one. From 8.5 to 9, we have 1 person. So we drag 8.5 up here and down over to 9. This means when we raise it to the 1 bar level, that we have 1 person in this section. I don't need to color it all the way for you to see, but I will. Then we have 9 to 9.5, where we had 4 people. We had the 9.3, the 9.4, the 9.1, and the other 9.3. So this section would go up to 4 people. And I'm not going to color that in because that would take ages. Now we move on to 9.50 to 9.99. There's only 1 person in that section, which was the person who timed 9.8. So we draw from 9.5 to 10 to 9.99 to 10. We draw to the 1 level. Something around the lines of there. Oh. Now we look at 10.00 to 10.49. This has 2 students, so we raise it to the 2nd level, to the level where there's 2 people. So that would be 10.00 to 10.5. Now we look at the next section, which is 10.50 to 10.99. Again, we only have 1 person in this section, which is the 10.5. Take the 10.5 and we raise it up here and we scoot it over to 1. I realize my graph isn't perfect, but just go with it. Alright, now we're looking at the section 11.00 to 11.49 or 11.5. So for this graph, there are 2 people. So I draw it roughly to this level and bring it down. Now for our final section, which is 11.5. We are doing problems 13 and 14. Let's start with 13. For 13, we have the question, what is the median length of these names? We have a chart with the number of letters in a name and how many students have that. So this is 3 letters, 4 letters, 5 letters, 6 letters, 7 letters. We can make a set out of this. A set would be much easier to find the median of than a bar graph, as we have an idea of how to find the median there. So we can write 7 3s, and then we have 3 4s because 4 goes to 3, 1 5, 4 6s, and 4 7s. So this set is much easier to use than this bar graph because we know how to find the mean, median, and mode of it, but we want to find the median. So there are 19 numbers in this set, so we want the middle. So the 10th number would be the middle since there are 9 numbers before it and 9 numbers after it. So we look for the 10th number and we see that it's here. So this is not only the 10th number, but it's also the median. So this is the median. and the 10th number. So that means the median and the answer for this problem is 4. Next, we have a complicated problem. I have allowances of $13, $17, $24, and $30, and X dollars. If the mean of my allowances equals the median of my allowances, then what are the possibilities for my 5th allowance? Well, there are 3 possible medians here. X can be the median, 17 can be the median, or 24 can be the median. Let's start with the case where 17 is the mean and the median. After all, mean equals median. So then the numbers have to add to 17 times 5, which is 85. So right now we have the numbers 13, 17 adding to 30. 30 plus 24 is 54. 54 plus 30 is 84. So X equals 1. So since we have 85 needed and 84 we already have, X will be equal to 1 because we only need $1 extra to make the average 17 along with the median. Now let's work with the case where X is the median. If X is the median, well then we can take X out of the mean equation because X just simplifies itself out because X is the mean. So we literally just take the sum of the numbers, which is 84, and divide it by the number of numbers left, which is 4, and we get this equal to X, which is also equal to 21. So far we have the solutions of 1 and 21. Now let's take the case where 24 is the median. So 24 also has to be the mean. Since there are 5 numbers, we take 24 and we multiply it by 5, and we get 120. Now we take 120 and we subtract 84 from it because the 4 numbers we have, I'll do that in blue, black for you. The 4 numbers we have, these 4 numbers, they sum to 84. These guys sum to 84. So we would subtract 120 to 84, and we get X is 36 in this case. So we have 3 possibilities for X. There is $1, $21, and $36. As the median can only be 17, 24, or X, we know that there are no other solutions. So there has to be 3 solutions, and we have them 3 right here. That's a wrap. We are starting with question number 15. So we have in the set above. The set above is 3, 4, 5, 6, 6, 7, X. The mean is equal to the median, which is equal to the mode of the set. What is X in the set? Well, we obviously know the mode. The mode is the number that appears the most. In this case, the mode is 6. The reason we know the mode isn't any other number is it says that we have a unique mode. So if X was 7, 5, 4, or 3, then we wouldn't have a unique mode. So the mode is 6. So this is our mode. This is also our mean and our median. So we have that our mean is equal to our median, which is equal to 6. So the numbers will sum to 42 because we have 7 numbers, and since the mean is 6, we would multiply 6 times 7 to get the sum of the numbers. So 6 times 7 is 42. So the sum of the numbers is 42. So we have that 3 plus 4 plus 5 plus 6 plus 7 plus 6 times 2 plus 7 plus X equals 42, which is equivalent to 31 when you add these up. When you add this up, you get 31. okay? And you just have x, so 31 plus x. If you subtract 31 from both sides, you get x equals 11. So, we know the answer to our problem is 11. Let's move on to problem 16. Problems 16 through 18 will use the following information. We know that sac A has 0 for median. 0 is the median. A question mark, we don't know the mode. And 600 is the mean. For sac B, 900 is the median. We know the mode is 0. And 80,000 is the mean. For sac C, we have 1200 being the median, 2000 being the mode, and 900 being the mean. For sac D, we have 20 being the median, 10 being the mode, and 85,000 is the average. So, now that we have this information, let's put it to use using these types of questions. Which sac has the most money? Well, for this question, we don't know how many envelopes are in each sac, so this is a bit of a problem. Because of this, we cannot tell whether sac A, sac B, sac C, or sac D has the most money. Because sac A could have like a giant $1 million envelope, but a bunch of zeros bringing the mean down, and sac D could have some average envelopes that wouldn't add up and would get this to be 85,000 only. So we don't know. So let me emphasize this. We don't know which sac has the most money. Let's move on. Problem 17. Which bag has more envelopes with $1,000? Which one? What about $10,000 in saying which bag has more money with $10,000? We assume that each bag has the same number of envelopes. All right. Since sacs A, B, and D have medians less than 1,000, at least half of the numbers. So we have half of the numbers. So that means, let's say, less than 500 have more than 1,000. However, for sac C, we see that it has a median of over 1,000. That means it can have more than 500, as it can have things below the median that are also involved in the over 1,000 group. So, sac C has the most for the 1,000. Not given any information for the 10,000, we are unable to conclude how much, which one has the most over 10,000, as our medians are too small for this to tell us. Our means, even though they're useful, they combine all numbers, so they cannot be used in this problem. So we can't determine for 10,000. But we can determine for 1,000 that it's sac C. Alright, if each sac has 1,001 envelopes, then what is the mode of A, and which sac has the most amount of money? Well, let's start with which sac has the most amount of money. If all sacs have the same envelopes, that means the sac with the greatest mean is going to have the most money, because it would have the most inside each sac. So we see that sac D has 85,000, which is bigger than all of these other numbers. This is bigger than the rest of these. So this one's the biggest. Biggest. So that means that sac D is this is the solution for question number 19. This question says, in this set, we have range equals mean equals mode equals median, which is equal to 8. What is the biggest number that could be in the set above? The set we have is here. It's x1, x2, x3, x4, x5, x6, x7, x8. So really all this tells us is that there are 8 numbers in the set. What does the median tell us? The median thing tells us that x4 plus x5 equals 16. Since we need an 8 in for the mode, we let x and 4 and x and 5 equal 8. If x and 4 and x and 5 were 7 or 9 or any other numbers, then they would block and exclude out 8 and we would never get 8 being the mode. So that means x4 and x5 are 8. So what does the mean tell us? The mean tells us that the sum of these numbers is 64. So the sum of the remaining 6 numbers is 48, of course. The range tells us that this number is, this number is 8 greater than this number. So now we need to trial and error things, because we know that in order to make x8 as big as possible, we need to make x1 as big as possible. x1 can maximum be 8, as the median is 8 and you cannot go higher than them. If x1 is 8, then we would have at least 72 being the sum of the numbers, because we'd have to have all 8s being, if we want the least, all 8s up here. And x and 8 would be 16, and we would get the sum being 72. So that won't work. Let's try if x1 is 7. Well, then x8 is 15. So that means 7 plus 15 would be 22. And 22 plus 8 plus 8, or plus 16, is 38. So that means we need a sum of 26. But when we look at these numbers, they can minimum be 7 or 8. Let's say x2 and x3 are both 7. That makes it 14. So now we need 12 as a sum. However, these two numbers have to be minimum 8. Otherwise, the set will. Otherwise, 8 will no longer be the median. So we have to put 8 and 8 there, giving us 16, which means we're way over our sum by 4. So we cannot do this. If we try x1 equals 6 and x8 equals 14, we can make the following set. 6, 3 6s, 4 8s, and 14 to satisfy the conditions. As you see, the middle number is 8. When you add the numbers, the sum of the numbers is 64, which is what we wanted. The range is 14 minus 6, which is 8. And the mode is 8, as we have 4 8s, even though we have 3 6s. This set would satisfy all the conditions, and hence, the biggest that we can have x8, the biggest number in the set, be, is 14. Hence, we are done.
Ready, set, go.
Let's work on the final problem, problem 20. The problem says, when the mean, median, and mode are organized in increasing order, they form a constant difference. What are the possible values of x? The mean, median, and mode of this set. The set is 10 to 10, 2, 5, 2, 4, 2, and x. First, we reorder the set in increasing order. We put it in order like this: 2, 2, 2, 4, 5, 10. We don't know what the value of x is, so we can't order it yet. Now we know the mode is 2. Even if x were 4, 5, or 10, there would only be 2 10s or 2 4s or 2 5s, and there are 3 2s already. so the mode has to be 2. The mean is 25x plus 7. We can show this because the numbers here add to 25. So we add 25 to x and we divide it by the number of numbers. So we have 1, 2, 3, 4, 5, 6, 7. So that is why the mean is 25x plus 7. If we have 3 cases we need to consider for x. If x is less than or equal to 2, you can go. Then we don't have a constant difference because the mode would equal the median, as we'd have some sort of set, let's say x 2, 2, 2. 2 would be the median, but 2 is also the mode. And mean is not equal to the median in the mode, so the difference would not be constant. Hence, this case does not work. All right. Moving on to the next case. If x is greater than 2, but less than or equal to 4, then we have the mode is 2, the median is x, because x will be between 2 and 4 in the middle, and the mean is 25x plus 7. We can try to find whole numbers, and we figure out if we add 3 to this, we get 28 over 7 is 4, and this is 3. So 2, 3, 4 is a sequence where we add 1 each time. Pretty basic. So that means one solution is x equals 3. If x is greater than 4, then the mode is 2, the median is 4 because that's what pushed in the middle, and so the mean must be 6 if we want to increase by 2. So that means that the sum of the numbers, the 7 numbers, is 6 times 7, which is 42. And the sum of the numbers we have right now is 25 plus x. So here, 25 plus x would equal 42, and x is 17. So that means the only possibilities for x are 3 or 17. And we are done for today.
Don't forget to subscribe and like. If you have any questions, you can email info@agouramathcircle.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email, but without the info and the end. So bye!